everyone, in this video we will discuss about the application of mole concept on chemical reaction. So before this we will study that analysis in chemistry can be divided into two parts. The first one is qualitative analysis and second one is quantitative analysis. So the qualitative analysis involves determination of chemical composition by using suitable characteristic tests and analytical techniques. So this qualitative analysis will be discussed separately in the different section. Probably we will study this into 12th class. And the quantitative analysis, that is involves determination of amount, and this amount may be moles, mass, volume of gases, or we can say that equivalents. So the determination of amount is called quantitative analysis and it is separately studied as stoichiometry. So what actually is studied in stoichiometry? Stoichiometry means determination of amount, and amount involves moles, mass, volume of gases and equivalent determination. So we will apply the stoichiometric concept while dealing the chemical reaction, and in this we will read application of mole concept on chemical reaction. So how we can interpret it, a balanced chemical equation. A balanced chemical equation, so first requirement that the chemical reaction which is to be dealt should be balanced. So we can take the analysis which is involved to deal the balanced chemical equation. The first one, it may be the mass analysis, and the second one is mass volume analysis, and third one is mole analysis, which is very important and advisable to deal the problems of mole concept by using this. And the fourth one is volume analysis. Let's understand the meaning of mass analysis. Suppose it is required to determine the quantity, find the amount of calcium oxide and CO2 liberated by decomposition of 1000 gram of calcium carbonate, which is limestone. So it is required to find the amount of calcium oxide and CO2 liberated by decomposition of 1000 gram of calcium carbonate. To deal with this, first we will write the balanced chemical reaction, which is CaCO3 on decomposition gives CaOS plus CO2G. Obviously, if we will deal with the mass analysis, then we will say that because 100 gram, this is 100 gram of calcium carbonate, and 100 gram of calcium carbonate gives 40 gram of CO2. So we can calculate the amount of CO2 liberated for the 1000 gram of calcium carbonate also, because 100 gram of calcium carbonate liberate 44 gram of CO2. So for 1000 gram of calcium carbonate, it will liberate 440 gram of CO2. In the same way, we can find the amount of calcium oxide that is liberated by 1000 gram of calcium carbonate. Very obvious, 100 gram of calcium carbonate gives 56 gram of calcium oxide. So the 1000 gram of calcium carbonate will give 560 gram of calcium oxide. In this analysis, because we have compared, we are analyze the mass with the mass, as 100 gram of calcium carbonate and 44 gram of CO2 and 1000 gram of CaCO3 and 440 gram of CO2. That's why this kind of analysis is called mass analysis. We can take what is mass volume analysis by using the same example. If it is required to find the find the volume of CO2 gas liberated at NTP for the same data in above question. It means that by decomposition of 1000 gram of calcium carbonate, what volume of CO2 will be liberated at NTP? So simply we can write the balance equation as we have written earlier, that CaCO3 will give CaOS plus CO2G. Again we will deal that 100 gram of calcium carbonate will liberate 22.4 liter at NTP. This is the quantity 100 gram which will liberate 22.4 liter of CO2 at NTP. So we can calculate the volume of CO2 which is liberated for 1000 gram of calcium carbonate. Definitely this will be equal to 224 liter. So because we are analyzing the mass and the volume of gases, this is called mass volume analysis. Now we will focus on the mole analysis, which is very important, as I told earlier, because this is very much helpful to solve the mole concept problem very easily, stoichiometric problem very easily, and in very less time. So what is mole analysis? Simply we can say that for the same question, CaCO3 on decomposition gives CaO and CO2G. As the 1000 gram of calcium carbonate is given, first we will find the moles of calcium carbonate given as moles of calcium carbonate, which is given will be equal to 1000 by 100, that will be equal to 10 moles. So obviously the stoichiometry indicates that this is 1 ratio, 1 ratio and 1 ratio. So 1 ratio, 1 ratio, 1. So 1 mole of calcium carbonate gives 1 mole of calcium oxide and 1 mole of CO2. So how we can compare this? 1 mole of calcium carbonate gives 1 mole of CO2. So 10 moles of calcium carbonate which is given will produce definitely 10 moles of CO2, because we have calculated the moles of CO2 as 10 moles. So we can calculate the other, like if it is required to calculate the volume of CO2 at NTP, simply we can say that 10 into 22.4, that will be equal to 224 liter. In the same way we can find the mass of CO2, that will be equal to 10 into 44, that will be equal to 440 gram. In this method we are basically analyzing, we are relating the moles with the moles. So this is called mole analysis. Students are advised to use this method as the accuracy of this method is high and the calculation is less. How we can write the mole analysis equation? Like for a chemical reaction, for a balanced chemical reaction, AA plus BB, this will give CC plus DD, where A, B, C and D are stoichiometric coefficient of this balanced chemical equation. So by using the mole analysis, we can write for this equation that moles of A divided by A, which is stoichiometric coefficient of A, and moles of B divided by B, and moles of C divided by C, and moles of D divided by D. This is stoichiometric relation by using the mole analysis. Now one more analysis in chemistry, which is volume analysis, stoichiometric, to solve the stoichiometric problems, which is studied separately in Stoichiometry, which is called gas analysis, in which we will relate the volume of gases separately. We can take one more example to explain the volume analysis. For example, if we are writing the combustion reaction of acetylene CO2G plus H2OL. So if the 50 ml of acetylene is given under identical condition of pressure and temperature, then we can say that 1 ml of C2H2 requires how many moles of oxygen? Definitely this required 3 moles of oxygen. So the 450 ml of acetylene, the volume of oxygen will be required, that will be 150 ml. So this is volume analysis, because we are relating the volume of one reactant or products with each other. In the next section we will discuss about the simple problems on stoichiometry by using all these kind of analysis. But as I told you that students are advised to solve the mole concept problems by using application of mole concept on chemical reaction by using mole analysis most. Thank you very much.